A green BGP neighbor is reassuring. It is not proof that the network service works. Established says that two processes completed session setup and can exchange BGP messages. It says nothing yet about the required address family, route policy, next hop resolution, installed forwarding state, or the packet on the wire. The rejected assumption is simple: session health equals service health. It does not. The core learning is that BGP must be proven as a 6-link evidence chain. Established answers the first question. An operator must answer the remaining 5. Here is our agenda. First, establish what BGP exchanges and how a session reaches established. Second, separate base session state from multi-protocol address family capability. Third, follow a received route through policy, preference, and selection. Fourth, resolve the selected next hop, including the remote VTEP beneath EVPN. Fifth, cross the boundary from the BGP routing table into operating system and hardware forwarding state. Finally, observe the expected packet and prove that forbidden traffic is absent. Each step depends on the one before it. Skipping a step converts evidence into assumption. BGP exchanges routes. In the base specification, a route is a set of destinations called network layer reachability information, paired with path attributes. The destination says what is reachable. The attributes describe the offered path. Policy controls what enters, what is preferred, and what leaves. This is why BGP is better understood as a policy-controlled database exchange than as a protocol that discovers a physical topology. It can carry IPv4 routes, IPv6 routes, or EVPN objects, but it does not prove that any of them can be forwarded. A BGP session is a finite state machine over a TCP connection to port 179. The 6 named states are idle, connect, active, open sent, open confirm, and established. Active is frequently misunderstood. It means the machine is trying to acquire a TCP connection, not that forwarding is active. Open messages negotiate session parameters and capabilities. Keep-alive messages maintain the session. Update messages advertise and withdraw routes. Notification messages report errors and normally close the session. Only in established can ordinary route exchange begin. Begin is the important word. Established proves 3 useful facts. TCP works between the chosen endpoints. The open exchange succeeded, and the processes can send normal BGP messages. It does not prove that the needed multi-protocol address family was negotiated. It does not prove that a route passed import policy, one selection, or survived export policy. It does not prove that the route's next hop resolves in the underlay. It does not prove that Linux or the ASIC installed the intended forwarding object. A green neighbor is evidence, but it is evidence for exactly one layer. RFC 4271 gives us a durable conceptual model. Adjacent RIB-in contains routes received from peers. Import policy and the decision process calculate preference and select usable routes. The local RIB contains the selected routes. Export policy then produces the adjacent RIB out for each peer. Implementations do not have to store 3 literal tables, but every troubleshooting workflow needs these distinctions. A route can be received and rejected. It can be selected and not advertised. It can be advertised and still fail to install in forwarding. Always ask which stage you are observing. There is no single, portable, vendor-independent best path mnemonic that is safe to treat as the protocol. The standard defines constraints and a decision process, but local policy calculates the degree of preference, and implementations add criteria and multipath rules. Higher local preference is preferred inside an autonomous system. AS path information supports loop detection and policy. The next hop must be resolvable. After that, exact tiebreakers depend on the platform and release. For EVPN, the practical lesson is simple. Verify why a path was selected on the actual software. Do not explain a decision with a memorized list from another vendor. Inside one autonomous system, traditional internal BGP assumes a full mesh. The reason is a propagation rule, not TCP. A route learned from one internal BGP peer is normally not advertised to another internal BGP peer. If A learns an external route, B and C each need a direct internal session to A. This prevents simple control plane loops, but the number of sessions grows as n times n minus 1 divided by 2. A 4-node fabric needs 6 sessions. 100 nodes need 4,950. Route reflection changes that propagation rule in a controlled way. A route reflector can advertise an internal BGP learned route to selected clients. This removes the client full mesh. Originator ID and cluster list help detect reflection loops, but the reflector normally selects a best path and reflects that selected path. Other valid alternatives can remain hidden from clients. Local multipath does not automatically fix this. Add path is a separate negotiated capability for advertising multiple paths. The reflector topology must also be congruent with forwarding topology or differing IGP costs, and policy can create surprising choices. Route reflection by session scale by centralizing part of the visibility and selection problem. Yes, multi-protocol BGP associates reachability with an address family and subsequent address family pair. It uses one attribute for reachable network layer information, plus its next hop, and another for withdrawals. Each speaker must advertise support for the same pair to exchange that family in both directions. EVPN uses the Layer 2 VPN address family and EVPN subsequent family. Therefore, the base BGP session can be perfectly established while EVPN is absent, disabled on one side, filtered at the reflector, or never negotiated. Check negotiated capabilities and per-family route exchange, not only the global neighbor state. A selected route becomes usable only when its next hop resolves. In an EVPN VXLAN fabric, the BGP next hop is normally a remote VTEP address. The underlay must provide a valid route to that VTEP. Then, the network operating system must translate the EVPN route into tunnel, bridge, forwarding database, neighbor, or next hop group state. Finally, the kernel, or ASIC, must realize that state. This is the control plane to data plane boundary. A route can remain visible in BGP while an underlay failure makes it unusable. Never count an EVPN route as forwarding proof without checking its resolved next hop and installed objects. These mechanisms solve different problems. Graceful restart can retain stale routing information while a BGP control plane restarts, attempting to preserve forwarding. BFD rapidly detects a failed forwarding path. Route refresh asks a live peer to replay its routes so policy or consistency can be re-evaluated without resetting the session. If graceful restart retains a path after its forwarding has failed, it can convert a fast failure into a stale black hole. If BFD is too aggressive, it can create false churn. The design must state which failure is being handled, which state is trusted, and how long that trust is allowed to survive. Proof is a chain. First, the session is established. Second, the required address family is negotiated in both directions. Third, the expected route is received, imported by policy, and selected for the intended routing instance. Fourth, its next hop resolves through the underlay. Fifth, the operating system and hardware contain the intended forwarding objects. Sixth, a packet capture or traffic test shows the correct packet, including the correct tenant or VNI, and negative testing shows forbidden traffic absent. Configuration proves intent. A show command proves one layer of state. Only the complete chain supports the claim that BGP is working for a service. Finish every BGP investigation with 6 questions. Is the session established? Is the required address family negotiated? Is the expected route present, imported, and selected? Does its next hop resolve? Is the intended forwarding state installed? Does the expected packet pass while the forbidden packet remains absent? Established answers only the first question. Do not take the remaining 5 on trust. Choose one expected route. Follow it from received advertisement to forwarding object, send one representative packet, and capture the result. That turns a green dashboard into an evidence-backed service claim.